Hello there. Welcome to this channel. My name is Dick van Oeveren, and in this video I will do something very cool. I will show you how to configure microsegmentation on a Aruba 10K switch. So this video series is all about configuring and setting up your data center network using Aruba OS-CX switches, Aruba Fabric Composer, and the Pensando Services Manager. And in this video, I'm gonna do, like everything. I'm gonna set up everything using the Aruba Fabric Composer. And just let me just quickly show you the diagram again, how to set it up. How everything is set up. It's really what you can see here is I have this vSphere host where I have two VMs connected, and you can see that these two VMs are in the same network. They're in the same subnet, in the same VLAN, 203.104 and 203.108. And so what I'm going to do is I will be configuring private VLANs on the vSphere host through a VDS, private VLANs on the switch, and so the primary VLAN actually, so VLAN 1203, that is the network that we will be redirecting to the DSM for traffic inspection. And that's the way we are getting microsegmentation on the switches and get isolation between hosts that are on the same network. Now, as said, so there's a lot of configuration tasks to do here, but we can do this in a very easy and very simple way in Aruba Fabric Composer, and that's what I will show you in this video. Let's get to it. Here we are in the Aruba Fabric Composer dashboard. And now, so before I start to configure microsegmentation, I just want to show you some information that actually what happens after I've created the microsegmentation. A lot of things are provisioned through AFC. One of the things is that so this interface 1/1/2, that's actually the interface that is connected to the vSphere host. And what will happen is that VLAN 1203 and 2203 will be assigned to this interface, right? So, and you don't see it at this stage. And what I'll do is I'll create that microsegmentation, and then after that's been created, I will go through all these other settings and show you that things have changed, right? So the ports will change. There is this VLAN groups. What happens when the VDS, when the virtual distributed switch is created on vSphere, it will also show up here. It will also show up in AFC. And what we'll also see is we'll see the private VLAN configuration here as well. With the creation of the microsegmentation, also private VLANs are created on the switches and provisioned. And then finally, the other things that will happen is that in the VRF, in the GVA VRF, we'll be creating network 1203. That's also done in the workflow, and we'll also create an IP interface for SVI, well, an SVI for VLAN for network 1203. And you can see that the 1203 is not in there at this stage. Okay, let's move to the visualization, and so that's the host visualization. Oh yeah, one other thing I want to show you is the vSphere host. You can see that I have two clusters here. I have the Dublin cluster and the Amsterdam cluster. There are, on the Dublin cluster, you can see two DVSs. On the Amsterdam cluster, I have one DVS, and actually what I'm going to do is I'm going to create a DVS on the Amsterdam cluster. Not through vSphere, but through Aruba Fabric Composer. So you will see the private VLAN DVS showing up here once I've went through the workflow. Okay, so visualization. I'm on the host visualization, and when I click on the IP address of the host or the host name, I have this option here, create microsegmentation. Let's do that. Let's give it a name, 1203 isolated 2203. I'm doing that on the host, and I need to select the VM NIC, which is the physical NIC going out onto the switch. Okay, I'm gonna add that, hit next. This section is for creating the port group, or port groups actually. I'm using private VLAN 1203, so that will be my primary VLAN, my promiscuous VLAN, and the isolated VLAN will be VLAN 2203, and that's the VLAN that is used to connect the VMs. I will assign this to the GVA fabric and to the GVA VRF. And you can see that there are no networks at this stage. And then this wizard will also allow me to create a network, say network 1203, which is now VLAN 1203, because I have assigned VLAN 1203 as the primary VLAN, and will take this this network. And I also can create an SVI here, an IP interface, which will be tied to VLAN 1203. I'm only going to configure that on the 10K1 switch, 0/24, so that's my subnet. And so only one switch, so I'm only going to specify one single IP address, 203.1. And the other thing that you can see is that we have this enable local proxy ARP option here. And the enable local proxy ARP is used by the switch. So typically what you have with private VLANs, if a source sends out an ARP request to get the MAC address of a destination, with private VLANs and isolated VLANs, the destination, well, that ARP request doesn't reach the destination. And what will happen with the local proxy ARP is that the switch, obviously the switch knows the MAC address of the destination host, and it will respond on behalf of the destination host. So the ARP request that's being sent by the source, the switch will respond on that. Okay, IP interface VLAN 1203. Apply. And so we've got that. Hit next. And now what I can do is I can also create a security policy in this workflow. So we have two options. I can create it here. I can also create a security policy in AFC itself. And actually, I'm going to do that because you'll get to see some more cool options and features when I do it separately. So I'll skip the policy for now. You don't have to do any policy enforcement here in this workflow. So I'll do that in a minute. Okay. And then it's just a matter of hitting the apply button. And then what will happen is that on the vSphere host, the DVS is created. The private VLAN configuration is pushed to the switch. And also the VLANs from that private VLAN are assigned to the interface. And you can see here, so the screen has refreshed. So you can see here now that the VM NIC is now connected to interface 112 of that 10K switch. I can click on this and I can see that VLAN 1203 and 2203 are assigned. You can see the DVS, okay, and you can also see the port groups. And of course, we don't have any VMs connected to the port group yet, but I'll do that in a minute. And also, let me show you what has changed. You can see now that VLAN 1203 and 2203 are assigned to interface 112. There is a VLAN group, which is the DVS. You can see here that this item is externally managed. So any modifications that you make you should use vSphere for that. And the other thing is the private VLAN configuration. And so you can see that there's also private VLAN configuration pushed to the switch. Going into the VRF, checking out the networks, you can see that network 1203 is here, has been created, and I also have an SVI VLAN interface 1203. Cool. And now, so because this network has been created here, it also exists on PSM. So when I check out PSM, I'm into networks here. You can see that this network 1203 is in here. And you can see that there are no policies applied here, which means that the VMs that are attached to network 1203, they actually use the private VLAN functionality, so they are isolated from each other, and that traffic is redirected onto the DSM, to the security chip. However, because there is no policy applied to this VLAN, to this network 1203, all traffic is allowed, which means that the two hosts, the two VMs, are able to communicate with each other. Now let me move to vSphere as well. And so you can see that this primary DVS has been created, primary 1203, isolated 2203, and I've got two port groups here. So this is the 1203, this is the primary VLAN port group, and this is the isolated port group. And now I have two VMs sitting here in the dummy group. So these are the 203.104 and the 203.108. And what I'm going to do is I'm going to move these VMs into the isolated VLAN. Okay, so they're in the isolated VLAN now. And so this is the 104. You can see the IP address here, 104. And actually what I can do is I can do everything. I can ping to 10.6.203.108. I can also SSH into the box 108. And that's because traffic, although traffic is redirected to the DSM, there is no policy enforcement. There's no policy applied to that network. So I can do everything. So let's create a policy. And let's do that in Aruba Fabric Composer. What I do is go into the configuration, policy, and then policies. And you can see that there's one policy, the block ICMP policy, which I have demonstrated in the previous video. What I'm going to do is I'm going to create a new policy, block SSH. It's distributed firewall. I want to use the DSMs. I want to use the distributed services modules on the switch to inspect the traffic. There's also options to create a layer 2 or a layer 3 ACL. I'm going to do the layer 3 ACL in a later video. I'm going to show you that. You can also do stateless firewalling on the switch itself, but in this case, it's the distributed firewall. And let's add some rules to this policy. Now, I already have a rule for any traffic because I've created that any traffic rule in the block ICMP policy. So I will select that existing any traffic rule, and I can also add new rules. Let me just add a new rule, say block SSH. My action would be to block SSH. And I can now also select endpoint groups. Now, what is an endpoint group? Let me show you that using the add button. So what I'm going to do is define network 1203 here, just give it a name. And in this section, what you can do is you can select the endpoints. It could be a VM, right? A VM name or maybe a VM tag. So you can use VM names or VM tags to select the endpoints. It's really cool. So for example, if I only want to use the 10.6.203.104, I can select that VM name here, or I can use tags. And the other option is that we use the manual endpoint entry, which is basically a subnet that you can do. And let me just do that. Just add that complete subnet. Basically what that means is that all the VMs in this subnet will be a member of that endpoint group. Okay, let me apply that. So my source endpoint group is now subnet 1203. But as said, it can be a VM, it can be a group of VMs. You can base the end groups on VM tags. There's a lot of stuff that you can do here to select specific endpoints. Okay, I'll just add the destination endpoint group as well. And yeah, so I want to block SSH. Now AFC already has some predefined applications, amongst which is SSH. And so that's being added here. And let's apply. And now you can see that I have two rules in here, any traffic and block SSH. Obviously, what I need to do is the block SSH should go up because that's the first rule that should be hit. And the any traffic, that's the explicit allow that we have as the last rule. Okay, and then where are we going to enforce this policy? Well, on the GVA fabric, on egress. Remember that egress means ingress for the switches. I'm going to apply it to the GVA VRF, and I'm going to apply it onto network 1203. Just add that, hit the summary button, so hit the next button for the summary, and that's really it, right? Before I apply, let's have a quick look at the security policies in PSM. You can see that there's no security policy in there. And let's check the networks. No policy assigned to network 1203. And let's hit that apply button. Block SSH is being created, and when I move to PSM, you can actually see that the block SSH policy is now assigned to network 1203. It's enforced, and my security policy is also created in PSM, and PSM pushes that security policy onto the switches. And that's all cool. Now let's move to the VM and see, I should still be able to ping to the 108. However, I should not be able to SSH into the 108 anymore because I am blocking SSH. And you can see that actually that is happening. So I cannot get access to that other host anymore. And that proves that microsegmentation is working. And just to put it to the test, let me just move back to PSM, to the networks, and let me just remove that policy. Just quickly there, no policy in there. And let's see if my SSH works again. You can see that I am on the other host again on the 108. Okay, so that's kind of like working fine. And let me just apply it again. Block SSH, save. Okay. So that's all working fine. Okay, now let me show you a different way of creating the microsegmentation. What I've done is I have reverted the configuration back, which means that there is no isolated or private VLAN configuration on vSphere anymore. I removed the DVS. I removed the private VLANs and all the configuration, the networks and the policies, everything is gone. Let me just show you that. I only have the block ICMP policy. no rules, no block SSH rules or anything. The VLANs are not configured here on interface 112. There's no private VLAN config, and there is also no DVS information in there. So everything is reverted back to the initial situation. And so in the first demo, I showed you how to create the microsegmentation from this option here in the visualization. But there's also another way to configure the microsegmentation, and that's through the policy menu. There you can see this option here, microsegmentation. I can go there, and then what you will see is you'll see an overview of all the distributed switches that are configured on the vSphere hosts. And what I can do is I can just click on add here and create that microsegmentation here, which I will do. So that's the .22 host, and that's the main difference, because in the visualization I already selected the right host, and in this workflow I need to select the host on which I want to configure the DVS. Okay, go next. Just give the port group a name, my primary VLAN and my isolated VLAN. I am assigning this to the GBA Fabric and GBA VRF, and I also need to add the network, right? So that would be network 1203, using VLAN 1203, which is the primary VLAN. I'm going to add the SVI as well. Just add it to the 10K1. You can see that local proxy ARP is ticked by default, because that needs to be enabled. Okay. So we're good there. And then next we can create this policy. And what I'll do now is I will create the policy in this workflow instead of going back into AFC. Let me just add that policy here, block SSH, distributed firewall type, and let's add some rules. Add the existing rule, which is the any traffic rule, and add a new rule, which is the block SSH rule. Drop. Okay, so adding the endpoint groups. Again, we can either choose to use the VM information like the VM name tag or VM kernel adapter, but I'll just use the network. Okay. And I'll use that in the destination endpoint group as well. Applications. Nope, sorry. There's SSH in here because that's an existing application. And apply. We have to reorder because of the explicit allow at the end. And then finally, let's enforce it. GBA VRF. And actually what I need to do is I need to clear this one and assign that. Oh, sorry. I need to add it here. Okay. Go to next. And so that's the policy creation. And so when I hit the apply button, well, a lot of stuff will be set in motion. The DVS will be created. The private VLAN configuration, VLANs will be assigned, and also the policy will be assigned. So let's hit the apply button and see what happens. And you can now see that the DVS has been created here. Primary 1203, isolated 2203. Let me check out the vSphere host. You can see that this one has been created as well. And okay, so let me also just right away move the VMs to the right port group. Okay, so they're good now. And let's move back and check out the visualization. You can see that the DVS has been created here, the port groups, and you can see that, well, actually I need to do a refresh, I guess, to see both VMs connected to that port group. There you go. Got the 104 and the 108 here, and all the way connected up to the 10K. Let's check out the ports. 1203, 2203 on interface 112, and the VLAN groups, there you go, and also the private VLANs, you can see that here as well. So that's all good. Let me also check out PSM. You can see that a network has been created, network 1203, and the block SSH policy has been applied to egress. And you have the block SSH policy here with both rules in there. So everything is done through Aruba Fabric Composer. And obviously I want to put this to the test as well. I'm on the 10.6.203.104 here. The policy has been enforced, so that means that I should be able to ping, which is good, but I should not be able to SSH. And you can see that SSH is blocked. And finally, let me show you some cool stuff. And so I actually want to see the flows, the flow information. And what I can do is in the security policies in PSM, I have this option called network graph. And in network graph, what you can see here in the NetSec summary, I can see the unique flows that are going through the DSM. And now what I can do is I can right click and do a search on the 203.104. What you can see is I have a couple of flows here. And one of the flows that I'm interested in is this third flow going to 203.108 destination port 22, because that's the SSH session. And what I can do is I can click on the flow details. And what you can see here is from a timing perspective. So these are all like historical flows, right? But if you take the top one here, the top two, is where you can see that the source is 104, the destination is 108, my destination port is 22, my action is deny, which means that this flow is being denied, and the policy that's being enforced is the block SSH policy. There you go, with the block SSH rule name. So as you can see exactly which rules are and which policies are triggered. And that's pretty cool. Well, and that concludes this video covering microsegmentation on the Aruba 10,000 switch. Next is a video where I will show you how to work with security policies in a mixed environment. What that means is that I have non-10K switches, I want to do security enforcement between the hosts that are connected to the non-10K switches, and I want to do policy enforcement on the 10K switches. And that's something that I'm going to show you next time. So I hope you liked this video. Again, suggestions, feedback, very welcome, and I hope to see you soon. Okay, bye now.